Welcome back to GlassBuild America. I'm Ellen Rogers.
And I'm Drew Vats.
Drew, do you remember last year at GlassBuild, we met up with a little guy named Herbert?
I do, you saved his life.
I did. He was kidnapped, and after the kidnapping, he had to change his identity. And he's now called Service Harry.
Nope.
And I think he's here.
I have an inside track on that. Well, that was fun.
Yes.
And I'm glad that Service Harry is alive and well.
Yes, good to see him.
And it's been good working with you the past couple of days, Ellen. This is our annual get-together, but I have some other things to see.
Likewise, I'm gonna take off and catch up with some folks, and I'll catch you back here later.
Sounds good to me.
All right.
Ellen, one of the products that everybody's excited to hear about, of course, is the next Intercept. And I see you've got it here.
We do.
I also see a thermal break in there, so I'm hoping you can explain how this comes together and what's the next version like?
Sure. So basically, this is a result of a collaboration between GED, Vitro, and Technical. And what we've done is taken Intercept to the next level of thermal performance by putting a thermal break in the back of the spacer. So Techniform is, our competence is precision plastic extrusion and co-extrusion with metal. What we do is we co-extrude two metal strips with a plastic to create a thermally broken strip. And then when you run this on the GED Intercept machine, you turn it into a U-channel spacer.
So that comes, I'm assuming that is a roll?
It's exactly right. This comes on a roll from
Okay.
Techniform. So it's going to help window manufacturers meet the new Energy Star manufacturer requirements.
Are there any factors that make it easier for fabricators to install and use? I mean, you have the machinery, you can create, you create the spacer, but what about installing it in the units?
Yeah, I mean, basically it has the same benefits as the regular Intercept system in terms of rapid throughput and ease of implementing into the IGU. So you're basically not compromising on any of the processability, but you're getting the highest benchmark thermal performance.
So that's a look at the latest Intercept. Now, let's have a look at how it's put together. So Joe, we've had a look at the latest Intercept, right? Intercept Extreme. And pretty impressive material, the way it's put together. And now you have a machine that's designed to actually assemble and shape the spacer, right? The finished spacer. Absolutely. How early were you in the process? Were you working in conjunction with other companies for a long time?
This machine, this Intercept 2.5, this generation, came out in 2014.
Okay.
All right. For the last several years, we've been working in conjunction with Vitro and Techniform, in this case, our partners, to develop the next thing, right? So it's developing the material, it's developing the bond, it's developing the compound, it's developing the machine, it's understanding the testing, it's going through all the modeling. So it's been a long, laborious process, and it's all come to fruition here today, this week at the show, really.
This is the first machine you said, right?
This is the first machine. It's been sold to our partners at AMSCO. Now, the base point for the Extreme is two pieces of 8,000 stainless steel bound together by a compound, a polymer in the center that gives us that thermal break and the ability to get actually the best thermal performance of any spacer in North America.
So in this case, I'm wondering, you said you were kind of early in on the process and you collaborated on this. Is that what it takes, like for these days, if you're going to do something like that, a new material, you've got to get everybody in
We believe so.
Yeah.
And our engineering team is part of the development of the material and the compounds. We had input to, well, this might be too brittle, well, this might be too flexible. We had to do something that would not only work and hold the metal together, but stand up to the robust nature of what we're doing with it, right?
And now let's have a look at how DuraSeal is put together. So Scott, we were just talking about following demand, right? Like what the market is requiring and wants.
Yes.
This is one of the lines that you said is in high demand here in the United States.
Yes.
Tell me a little bit about this one.
Yeah, so Pharrell, again, in partnership with our customers, thought it would be prudent for us to develop a new system for the automated manufacturing of the Quanix Duralite and Duraseal spacer, which are a single seal spacer. So what does that mean? That means that you do not require to put a secondary seal on the IG unit, but it also demands that you're able to process the unit through each one of the individual modules in a very precise way to ensure that that unit has reliability for a long period of time.
And you said there's some flexibility with this line. I mean, what are you able to adapt?
Yes, so the primary flexibility that we get with this line is that we can process both Duralite and Duraseal within one platform. And that also allows for the customers that are currently potentially doing it manually to move into automation, reduce labor, which is still typically very hard to find, and again, produce a very high quality unit.
And then of course speed.
Speed,
So
yes.
what are we talking here in terms of units and output? Can you give us some figures?
Absolutely. So for a unit that would be fully gas filled, 36 by 24 inches, we're looking at processing that unit every 24 seconds.
Well, that's it for us, Ellen.
That's it, but we've still got a little bit more to bring you from the show, so keep watching.
That's right, and follow us on social media.